Where is it? One plus one, two. Welcome in. Um, Now it should be fixed. Slim, thank you for the raid. I hope your stream was good. Welcome in, everyone. I'm just fixing an alert quick. Let's send a test alert. Why not? Okay. I changed how the first redeem works, and the sound didn't play because I forgot to fix that. But it should be fixed now for the future. Existing? Oh, okay, Eldritch. Can do. Okay, so I have zero plans for what I'm gonna study right now. Oh my god, we're starting off strong with this song. Bobos, hello. Hope you're doing well. Okay, free mathematical lessons for free. You're doing it very well. It's a threat for destroying humankind planned. That's fair enough, Eldritch. You raise a strong point. She'll drive to and from the big city today. Ooh, okay. Clonk just did something. Like sorry, it's got like a weird like pop up. It's nice. Well, I hope your day in the big city was good. I think we might do relativity for our setting. I feel like I did most of the interesting stuff from complex variables so far, and I need to get reading. So I don't even want to think about chapter 7 because chapter 7 is ridiculous. You know what? 8 was one that I was kind of interested in thinking about. Your complex analysis exam this evening, Matthew? Oh, I hope it went well. Sounds good, Hildrich. Oh, you know what? That reminds me. Oh, there you are, Clock. Thank you so much. Chowder, dude. How's it going? Clonk, thank you so much for the rating. Maybe laugh when you accidentally hit like the collaborate thing. Beaker, hey, Drummels. Hey, I remember you, Drummels. It's been a minute. Yeah. For anyone who's new around here, I'm Don Factorial. Until very recently, my name was Don Does Math. I do math help streams, but I also do game streams, and Daisy is one of my favorites. And that's how I know Clunk. So yeah, I usually play Daisy about once a week, and then 3 days a week I do math stuff. Producer here on my end, Clunk is an awesome dude. I was just watching him make some emotes, but he also streams Daisy. He's a cool dude. But yeah. Thank you, Clunk. Actually, you're not giving me a headache with math. Yeah, that's fair enough, Dropples. I completely appreciate that most people don't like math, and that's completely fine. I have exercises. One about I don't know how you pronounce that. Poincare uniformization theorem. Patient determining holomorphic functions in the uniform limit. Oh my god. I'm glad I'm not doing that kind of complex analysis. It sounds crazy. The Demolsky misadventures. Yeah. Dude, I was just trying to play the Mulsk last week, and then half an hour in, I get randomly kicked, and of course the queue is like 15 people deep or something. But yeah, even when I can actually stay on the Mulsk for more than half an hour, I usually just spend most of my time failing. um, but yeah, so when there are questions from chat, I kind of pull things from textbook that I'm interested in to study. And I've been doing a reading group on. I went a little crazy, and I started a reading group on general relativity, which is more of a physics things, but I've been liking physics too. And I've been getting my ass handed to me by this textbook. Um, I really do not understand most of anything that's happening, but I've read through chapter 7, and then I feel like that's an accomplishment on its own, even just reading the words, you know, if I don't understand them very well. The reading group hasn't quite discussed chapter 7 yet, so I'm pulling a problem from chapter 6. And chapters 1 through 5 are like all just prerequisite stuff. Like chapter 6 is the first kind of real-ish chapter, but even though we're not to the real meaty general relativity stuff, is pretty like it's later on. Yeah, chapter. It's like it's because there's some people who like I stream for themselves or come around chat who are really like into physics, and they keep raving about how cool general relativity is, and I'm like, okay, how hard can it really be? It turns out the answer is very. Let me turn the music down a little bit. I just turned it for that one song before. But the concepts of it are kind of fucking crazy. Like just this being the way that reality works is kind of mind blowing. Oh wait, Matthew, are you learning general relativity also? What kind of degree are you doing? I assumed you were doing just something that was like straight up math. Um, where in this chapter are they doing stuff with the waves? I need to learn more about waves in general. I know very little about waves. This was a wave one. I think there's another one though. Are they two core scientific? Oh, interesting. Astrophysics and quantum optics. Both those classes sound crazy. Quantum optics. Oh my god. Light work. Yeah. There had to have been another part where they discuss waves somewhere in this chapter, right? Apparently not. Okay. Optics with probability. Okay. Which maybe it's in chapter 5. Takes the two most crazy courses possible. Yeah. Ugh. What level degree are you doing, Matthew? Like, is that for a master's? Um, okay, this is the type of equation that we may or may not need. The sudden fabric of our being can't figure out how to not die of pneumonia in a video game. Ugh. I don't know if you've been doing it recently, Chowder, but I remember like I worked on you play. I've lurked on you playing it in tens a bit, and you're like talking about how you need like a medical degree to play on that server. I think he even showed like a chart with like all the different medicines and stuff. That looks kind of crazy. Actually, I don't know if this is what I want. I feel like this isn't what I want. It's good fun. Yeah, I've been kind of like scared to try because it just seems like way too much. Okay, maybe it's not. Okay, you know what? Fine. Let's just actually read the question and see what's actually asking because I don't think I've even done that yet. I saw that there's an omega in here. Photon frequency omega star is like a particle gravitational mass h bar omega star with c squared. Energy k equals h bar omega. Interesting. Okay. The Newtonian idea is calculate the kinetic energy lost to a photon that is emitted. It serves as a spherical star of radius r and mass m and escapes to infinity. Oh my god. What is it losing energy to? Maybe that is the Doppler shift. Wait, we need equation 6.14. Where are you? Oh, I don't know why I didn't grab this equation. You do graduate school in American standards, but your school requires you to do a lot of extra work besides the master's, like 2 courses outside math, 1 course in foreign language. That's super random. Or, I mean, I could see needing to know English to be able to like read academic papers and stuff, but yeah, that does sound crazy. Probability density function. I learned about those. It's been a minute, but um, like a probability density function, most people will have seen. Well, they maybe haven't seen the actual equation for it, but like the bell curve, Gaussian curve, that's a probability density function. You use them to, yeah, it's kind of as Matthew says. It's like if you have a continue, it use it to represent probabilities for things that are continuous. Um, like the heights of people, I guess. Actually, your biologist studying Beacon, you might you might be expecting like a different type of explanation than what I'm saying, but um, the issue with things that are continuous is that there's uncountably infinite. There's an wait, uncountably infinite amount of real numbers. Even if you just take a section of this Gaussian curve, there's still uncountably infinitely many numbers in that interval. And so it doesn't make like if you tried to assign a non-zero probability to individual numbers, like just right there, you would like blow up to infinity because there's just so many possible numbers. So what you do is you just talk about intervals and you get the area under the curve with an integral. And that kind of matches up nicely because with integrals, the integral from a to a of a function is just 0. So it's kind of a weird thing where um, the probability of any one particular thing happening is 0. But one thing still happens though, and it's just kind of a weird thing. Yeah, well, it's got, I think it was like engineering statistics or something, the class that I took. And it was actually someone who didn't really like stats beforehand. It was actually kind of a cool class. Oh, nice. Yeah, the real analysis. Yeah, I maybe shouldn't have used the uncountably infinite idea if I didn't know that you knew that or like what that means. Hey, Silverbird. I feel like I haven't actually watched it, but I think Three Blue One Brown has a video on that idea where kind of that seeming contradiction where the probability of any particular thing happening is 0, but one particular thing still happens. Like the probability of finding a person with height exactly, I don't know, like 5.5624 exactly feet is 0. But there's still someone with that exact height. I mean, well, probably. I don't know. Ooh, biology mentioned that brings Jasu out of the woodworks. A biologist kid. I like that. Okay, second question about this question. If we're pretending it has a mass h bar omega star over c squared, how the hell is kinetic energy not 1/2 of that, right? Because it's 1/2 times the thing we're pretending to be mass times the velocity squared. So where does the 1/2 go? Graph theory? Oh my god. I'm just gonna blindly trust the book saying. I guess the only thing I can do is just blindly trust what the book says the kinetic energy is supposed to be. Graph isomorphisms. Can you have a graph that's isomorphic to the integers like mod 5 or whatever? I don't know how what that would mean. To be honest, I never actually studied what an isomorphism actually is. I just kind of, from context, know what a little bit about what it's about. Compare graphs and match them up. Oh, I guess graphs are isomorphic to other graphs. That would make more sense. What am I supposed to do for this question? What is equation 6.14 actually telling me? Equation 6.12. Yeah, Jasu's doing some cool work, it sounds like. Wait, have you still not defended your dissertation, Jasu? It's June. Or are you still waiting? No, I'm not using AI. Um, I wouldn't mind AI as a way to review things that I already know, but I wouldn't really trust AI to teach me something new that I can't verify for myself is right. And in general, I'm just kind of a boomer when it comes to AI. I don't really like it. It's the way of the future, but I'm just delaying how long I accept it, I guess. You said you and procrastinate, so you gotta finish your thesis. Oh, okay. Hey, mouse. Nothing much. Hope you're doing well. Uh, Maybe I need 6.12. Is that? See, no, this question is an S, which means that it's allegedly straightforward. If it escapes to infinity, does that mean it's losing all of its kinetic energy? I guess it shouldn't be. I don't know. And I feel like, why is the only variable here omega star? Everything else is a constant. Wow, that's kind of surprising. That's surprising to hear that they embraced AI in that way. Do they specifically say Claude? Or like AI in general. Terrence House says that too. Wow. I mean, AI is like a really cool, like mind blowing thing that it's possible. Um, I just don't like that it's going to grow completely unregulated, unchecked. Uh, and so I just don't quite trust what people are going to do with it. Like, I don't think people are only going to do good things with it, which is why I just don't really like using AI. I sold out to factorials. I sure did. Use ChatGPT as a reviewer too. I mean, that's not a bad use of AI. I think it's also, and so even if AI is used only for good things, the other reason to not become too reliant on it is that I think it's going to make it too easy to avoid like thinking critically for yourself. People can just ask AI what they should think about something and not work through it for themselves. I don't know. It definitely does have very good uses, though. It just, I guess it needs to be used in moderation. JVD teach you how to cook. That's interesting. And that's another place where that's probably a really good idea. It makes up all kinds of math. Yeah, I mean, someone gave me a competition integral once, and neither myself nor anyone else in chat could figure it out. But someone plugged it into Chat GPT, like they paid for it and gave it to the most like up to date version, and that thing seemed to solve it, and I couldn't find any mistakes in its work. Hey Lucas, that's a good thing the math gotta understand it, not just shit something out of your leg. I haven't heard that expression before. Shit something out of your leg. Yeah, it's pretty hard to, well, I would say it's pretty hard to BS your way around math. But I think there are some areas of math where you probably could BS your way through some things. Yeah, Jasu. It's always very sure, like sure of itself and speaking confidently. I'm really confused about what they want in this question. Using Newtonian ideas, calculate the kinetic energy loss. So, are we losing kinetic energy to gravitational potential energy? That must be it, right? Wait, why is this omega star in this omega? Is that where the 1/2 went? Is omega equal to 1/2 omega star? I want to, okay. Let's check the errors, because that, I can't tell if that's a typo or not. Shake something out of your sleeve. So that was a Lucas special to edit that to shit out of your leg. It's a Lucas original expression. I like it. Uh, $132. No, you're standing by it? Okay. So the only thing I can conceivably think that we're losing energy to, can we be losing heat? No, if we assume space is a vacuum, there's no other particles to transfer the heat to. Maybe there's some energy radiation thing, but I assume that's not a Newtonian idea. But if we're getting infinitely far away from the star, aren't we getting infinitely... Well, this won't be G. Do the kinetic J's and basic mechanics stuff with the analogy. Okay, I don't think we want this. I assume that's not what I want. Okay, so maybe omega is a variable here that we plug things into. What would shaking something out of your sleeve? That means you're BSing? Is that like if someone has a card and why is my camera off center, by the way? It's a little better, right? Like if you have a card like hidden inside your sleeve and someone like catches you, I guess. You have to compute the gravitational field of a sphere of mass m. Use it to compute the kinetic energy at infinity. Well, the part we're getting confused is that, well, okay, well, the gravitational field, or I guess like the potential of a sphere of mass m is going to be the mass times like I need the acceleration of, due to gravity for a star. Like I want to do mgh, but it's not that simple, right? Gm over r squared. Oh, right. Uh, Thank you. And then we're gonna multiply by r, and then we need to normalize it. We can set 0 to be the surface of the star. That seems reasonable, right? Nope, not that r. No, not a 1. Because we don't even talk about a potential difference, or a difference in potential energy. It does be weird to have an m squared. I feel like m shouldn't be squared. Uh, why is this confusing? I must be conflating two different things, I think. I It should be this. I shouldn't have a second m, I don't think. Um, minus gm over r. Oh, so the change in potential must be the same as the kinetic energy? Is that the idea of what you've done here, Matthew? And so if we're doing it basically yes, okay. I assume we would set kinetic energy equal to potential energy for this part of the question. And we just divide over h bar. I assume the sign isn't particularly important. It's total energy. Hey, Ashu. Total energy. Um, I don't know what that means here, I guess. I'm kind of assuming that when the photon is first emitted, it has only kinetic energy right at the surface of the star. And then as it goes out to infinity, it loses all of its kinetic energy in favor of potential. But maybe it still has some kinetic energy because of this idea. Minute speed of kinetic equals h omega. Convert it to potential energy a bit, compute the difference, and you have final energy. Actually, am I enjoying the struggle or the happiness at the end? I guess I'm enjoying the struggle because as annoying as it is to be stuck on things, that is how you learn. What do we do with this E thing? Is E equal to MC squared? Stress yourself for your brain to market it. Yeah, Frank. So hey. But yeah, and someone who plays games like video games like Dark Souls and stuff like that, where kind of the point is to struggle, so I'm no stranger to it. It can be a little annoying to do this on stream because I feel like it's not necessarily like good like content, but I don't know. This is just how you learn. Um, so what I want to do here is isolate omega, but I assume we need to do something. We need to get rid of the E somehow. I just don't know, like, what is the total energy of a photon? I feel like the energy of a photon is just h bar omega. Like that's what we already used for the kinetic energy, isn't it? Statistical mechanics, Prem? No, I've never studied it. I'm sorry. Um, First order and 1 over c squared. Omar, I don't quite understand the question, so I can't truly explain it, but it comes from a book on general relativity. And this is supposed to be a straightforward question about uh, pretending that it's okay to apply regular Newtonian ideas to a relativistic situation. And I assume we're going to find that it's actually not a bad approximation, or that's pretty similar. But we're applying kind of the idea of normal kinetic energy to a photon in the Newtonian sense. It might also be that too, Frank. I'm not sure. I do have the answer key, which I plan to check after this. The field equations are probably going to be, those are really deep in the book, I think, and I'm probably not going to get that deep, unfortunately. I'm pretty early on in the book, and I'm struggling really hard with it, so it's very unlikely that I get there anytime soon. It'd be great, though. I would love to learn them. I learned Maxwell's equations last year, and that was awesome. Hey, Sandcall. Um, okay, I don't know what the hell you do with this E. Uh, I'm just gonna. I kind of just want to go with my original thing that it should be equal to 0. Now, I guess this would theoretically be my answer. That would be compared with equation 6.14. The issue is that they're asking to first order in 1 over c squared, and I don't have c anywhere in my answer here. Or it, no, I don't know what that's what they want here. I'm going to bring up the solution key, and I'm going to try to read through it sentence by sentence. Uh, and see if I can stop and figure out the rest of the problem after a certain point. Which k are they making h omega? Oh. Huh. Um, no, go for it, Frank. Um, I I tend to learn what people's backgrounds are, and just like I keep that in mind when I read the things that they say in chat. Um, you're always welcome to ask quick questions like that. Certain tuning loss of energy be what requires to snap the gravity connection. Yeah. For going out. Okay, yeah, fair. For going out to infinity. The difference in potential between touching and at infinity. I guess I was doing wrong before with two m's. I was getting an m squared. It should have been big M and little m. Um, the difference in potential between touching and infinity, which is 0. Yes. And so that's where this is coming from. Uh, the gravitational potential, which I'm calling capital phi. Is that capital phi? It might be like that. I think it is like that. um, is the gravitational constant g. Sorry, it's the mass of the object times the acceleration due to gravity, which is gravitational constant, mass of the thing divided by the square of the distance, r squared, times the distance away. And then minus wherever you're setting zero potential energy to be. Sorry, I'm not really explaining this well. And so I'm setting zero potential to be right on the surface of the star, like, touching it. And minus GMM over R. If you let this small r, which is like your distance away from the surface of the star, go to infinity, you're dividing by a very large number, so this entire thing disappears. And you end up with just the GMM over capital R. Right, yes, I have. So yeah, we're setting the difference in kinetic energy equals the difference in gravitational potential energy. And so then we just solve this for omega infinity, the thing we actually want. Yes, Riddle. The h bars all cancel. Okay. And so I think this is right. This matches up exactly with equation 6.14. Maybe that's the point. Now, this equation down here was exact under the faulty assumptions that we made as part of the question. But equation 6.14 is an approximation. From what I remember. It can be made more exact, and maybe that's the point of the question. Wait, is it an approximation? Maybe it just happens to be the exact same thing. I don't think it is an approximation. Maybe they're just pointing out a case where Newtonian mechanics can get you the right answer if you... I don't know. Let's read through the rest of the solution and see if they discuss it. Oh, they sure don't discuss it. But if they're saying to first order in 1 over c squared, that must be an approximation, right? The gravitational redshift, you could calculate it more exactly if you don't keep it to first order. Okay. That question's allegedly an easy one, by the way. Or I mean, it kind of is relative to this book. The S means straightforward. Here's another S one. Think about this. Oh no, I don't. No, I don't know. It hasn't asked. I don't know how you do this. Uh, this is where they're doing some really fucky math. Poseidon, I'm sorry. I'm not good with the geometric progression arithmetic. progression stuff. How were they doing this? Is this in chapter 5 or something? Hmm. I can't find it in this chapter. I might just rage quit general relativity for now. Yeah, I can't find it. Not rage, but switch to a different topic. Yeah, Frank, it is a pretty mathy exercise. I just had never learned the math behind it, and they go through like one example of calculations somewhere where I can't find it in the book, and I really don't understand it. So even though it's straightforward if you understand it, I sure as hell don't. Hey, Cersei Samuel, how about you? Bonayolo, I can only really do basic physics. I'm not very good with it. Yeah, Frank, exactly. Um, I also don't quite understand what they're asking with the very final question. Are the ladder curves with longitude distances between 2 points? Like, are they what? Are they between 2 points? I sure hope so. I don't know. Half the time, I don't understand the phrasing of a lot of these questions, not even from that one book. And they apparently make sense to people who study physics, but I just don't even know what the words that they're saying mean. Um, so I might do some complex analysis stuff instead because if I do too much relativity at one time, I'm going to get kind of frustrated. We did some of these during the reading group on Tuesday. Let me remember which ones we did. I want to do the other ones that we didn't do already. Yeah, Frank, there's also like, it's just like a phrasing thing. I don't know. B, C, and G are the ones that we didn't do. Cersei's, yeah, feel free to ask me a question. I see someone named Saka put a question in the Discord. I don't know who that is, but it looks like an A-level math. I guess it looks like that format. Oh, that's you. Okay. Okay. Yeah, Frank, I think that's what they were getting at. I just like I don't understand how you like change the path in some like the idea of trying to change the path is really I don't know how you do that mathematically. You know how to work it if you're not supposed to rearrange? I feel like you need to rearrange this. I don't know how you would avoid rearranging it. Were you told not to rearrange it? Oh, I guess I do know how you can do it without rearranging it in a way. Um, oh, you're talking about like it's defined to be that? I think you're still okay to rearrange it, at least in this case. But there's actually a completely different way we can solve this. I feel like you like you should be allowed to rearrange it unless like maybe there's some weird thing that your class is doing with that notation. But the only time you can't rearrange it is if you're trying to prove an identity. Like if you want to prove that sine squared plus cosine squared is one, here oh you okay, no, don't ask ChatGPT. You're allowed to rearrange it. The only time you can't rearrange something is if you want to prove an identity like this. If you want to prove that this equality is true, you need to start from one side and work from the other, or do some geometric thing for this one or something. There's a better example I could have chosen, but for here, like we're saying these two things are equal, we're allowed to rearrange it, but I actually wouldn't. I would keep things on their own side, for a reason that I'll show you in a second. I am going to work on the left side and multiply everything out. So let's distribute the 5m to each of these two terms. 30my minus 20m. Then take the 10, distribute it out. We get 30 minus 10my equals 10y plus n. Cosine is calling the answer. I guess we'll find out. So now I'm going to group the left-hand side based on the y's. So I'm going to factor the y out from these two terms. So we have a 30m. Well, actually, no, I'm sorry. We don't have to do that. We can just, this is 30my, that's minus 10my. Just do that subtraction. So 20my, and then these two things don't have y's, so they can go together. Okay, and so now we have to use a trick called equating coefficients. The idea of this trick is that there's some things that have y's, like the 20m, and some things that don't have y's, like the rest of that stuff. The only way this side can be equal to this side I think you can, but you don't want to rearrange Xerxes. Maybe there's some small thing that I'm missing here, but the thing that we're about to do is way more clear if we don't rearrange. So it's not a good idea to. Whether you're allowed to or not, I'm not sure. Um, the only way for the left side to be equal to the right side is if you equate coefficients. The thing with the y, or whatever is in front of this y, the 20m, has to be the same as whatever's in front of this y, the 10. So we can say that 20m is equal to 10 because the 20m must equal to 10. Because they both have the y's there. Similarly, the constants have to equal the constant, the things without the y's. So minus 20m plus 30. Hey, Nico, hope you're doing well. So the minus 20m plus 30, that does not have y's, and so it has to be equal to whatever on the right-hand side also doesn't have y's, the n. And that's how you deal with this. Yeah. So over here you get m is 1/2. You can take the 1/2 and plug it in here. Minus 10 plus 30 is n, so n is 20. Because why not? Hey, yeah, welcome in. I'm doing well. How about you? Hey, Shivan. So this is slightly different than what Poseidon got. I think I did it right, though. Ashu agrees. Okay. Yeah, no worries, Xerxes. It's a really nice trick to know. It's called equating coefficients. Okay. GCSE further maths. Oh, nice. Oh, your exam is next week? Good luck, dude. Yeah, the GCSE stuff I can help out with all day. So if you're into anything else, let me know. All right. So we'll go back to doing some complex analysis studying in the meantime. No worries, Xerxes. For B, I'm kind of confused. Why can't we just plug in Z naught? As long as it's not infinity, which it shouldn't be. Also, why is that to the side? Why isn't it underneath the limit? And so as long as Z naught doesn't equal 0, isn't it just this? If Z naught is 0, I think it's going to be undefined. Not infinity. Because you could also get negative infinity, I think. Might depend on M. Hero? Oh, maybe. Yeah, you know what? I wasn't considering negative m's. Uh, there's a lot of different cases to consider here, actually, now that I think about it. Hey, Krim, how's it going? Bu- 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 Well, I'm not sure. Hmm. If m equals 1, I think it does converge. Like, the limit as z goes to 1 plus I of just 1 over z, then it's just going to be 1 over 1 plus I. I don't think there's anything wrong with that. Oh, nice, Mitchell. If you have a question, feel free to let me know. I think m equals 1 is fine. I think m equals 0 is even more fine. And if m is negative, it's just going to be a polynomial. Air engineer, no, this is a complex analysis. So these are all complex numbers here. Because why not? I think we would call that rationalizing. Or maybe, oh no, you're right. I see what you mean with realized. I think I've heard that called rationalizing. I don't know if that's proper though. uh, I think no matter what m is, the limit is always fine as long as z naught isn't 0. If z naught is 0, we need to do some more thinking. It's kind of a weird question. So I was thinking this limit might be undefined because you could potentially get to positive or negative infinity. But actually, with complex numbers, that doesn't really make sense. There isn't you just kind of have infinite magnitude or you don't. Maybe it is just always infinity. I don't know, I feel like I'm missing something with B, but I, I, I don't know what it would be. Since m's an integer, I don't feel like we get anything wrong from different values of m. Oh wait, this is m greater than 0. If m is negative, we just get 0. I I think them both equaling 0 doesn't make any sense to check. Hey Deb. Okay, this might be my answer and I'm sticking to it. I don't know. Let's go part C. I assume we can just plug this in. I think sinh of I is completely fine. It's a continuous function, I think. Yeah, there's nothing wrong with this. We can probably evaluate it. What is e to the I? I guess that's just sine or cosine of 1. Oop. Okay, so we're getting just I sine of 1, I think. Oh, that meant, duh. I didn't need to do all that work. um, because we had this identity. Well, hey Obi. Yeah, these limits that I'm doing are complex limits, but yeah, like definitely those are first introduced in like Calc 1 or pre-calc. My pre-calc class did like the end behavior thing for limits to infinity. And maybe we talked about like asymptotes or something. We never did actual limits though. Okay, this is I expect our normal rules for rational functions to apply here, and we're gonna get 0 because the degree on top is, or the degree on the bottom is 2. So let's try and show that. How do we want to show that? I guess we just do I mean, there's a few different ways you can represent the same trick. Right now, I feel like factoring c squared from the bottom. Do I? Do I feel like that? No, I don't. Yeah, I do. So what we can do is we can write it as 1 over z over 1 plus 1 over z squared. And this limit evaluates, we get 0 on top over 1 plus 0 on the bottom. So 0. That's an odd number. Let's see if the book actually provides solutions for it. Section 1.3, it must have been number 1. Oh, lazy. That's not the right answer for B. It's not the only right answer, at least. Got C right, and I got G right. Okay. I disagree with their answer for B. They didn't do a very good job of that, I don't think. Let's think about number 2. It looked kind of intimidating. Like your institution, are they lazy? Hack, this is complex analysis. It's establishing a lot of Calc 1 concepts in complex numbers, though. Oh, yeah, Lucas, for that piece of the question. I definitely agree with that piece there. Do you next semester? Ooh, nice. I never took a class in it, but it's a pretty like complex analysis is pretty like well liked subject from people that I've talked to. Oh, nice, Jasper. Welcome in. Thank you. All right, so I hope I don't need to know the proof for Lopitals here because I sure as hell don't know it, and I've heard it's pretty hard. I have an idea for how we can not have to reprove Lopitals though. Are you expected to use it? I imagine you wouldn't have to use it yet. Something called Horner. Okay. Hey, Saha. What do I use besides U and V? R and S? I hate R and S. You've mentioned Horner before. I don't remember what it means. It needs A and B. I don't really like them either, but they're better. You know of Hornets? That's a good start, Jasu. But the math god cook, guys. Oh god. Far from it. Plus bxy bx. That's a lot of writing. There's not anything like biology, no disrespect. You don't even have the time. qRNA? Oh, I sure as hell don't. Maybe Jasu will know about it, but I never heard of qRNA, I don't think. Okay, but my idea here is um, we've gotten ourselves to a place where we can split this up into two purely real limits. Oh, this is inaccurate. Uh, oh, we're already using A? Oh my god. Bruh. B and C, I guess. Exam on logarithms next week. Good luck. If you have any questions about them, let me know. Electrophoresis. Cursed word ever. Dude, this is way too much writing. I am not paid enough. I'm gonna stop writing the x comma y. Thank you for the kind words, why? Jasper, so right now my schedule is just I stream on YouTube on Tuesday, Thursday, and Saturday. But Thursday is or like sorry, because I depending on your time zone, the days might be different. Right now for me it's Thursday, and on this day is purely a math help stream. The other 2 days of the week I stream, I'm doing not just math help. I usually do like reading groups for the first 2 hours of the stream, and then after that, I'll do math help for an hour or two. There's a friend of mine who does the exact same thing as me though. His name is Actual Education or Dr. Gold. He streams to YouTube as well. Hopefully this command works. Yeah. And so if I'm not around and you need help, he's also there. Empires have come up with Lenz's law. It's been a minute since I've done Lenz's law. Let me see. Right, it's the idea that it's basically the idea that a system tries to resist changes in the magnetic field. Sounds good, Jasper. Sleep well. Qualitative law, boo. This is a really helpful one. It lets you determine the direction of currents. Why does it resist? I don't know if there's a reason why. I think it's just how the universe works. Maybe someone who's better with physics would know. But as far as I know, I just kind of, I, I know that Lenz's case is a more specific example of a more general law that systems tend to resist changes in energy, or something that phrasing might be slightly off. But I think it's a thing in like thermodynamics, like a generalization of Lenz's law. And just for whatever reason in the universe that we exist, things tend to resist change. And Lenz's law is how that comes up in electricity and magnetism. So I don't know if there's a better answer to the question of why, but that's just because, I guess. If you're born in 1800, you've been the most famous inventor. I mean, if you had your current knowledge now and was transported back to 1800, I could see that. But if you have the education and nutrition or whatever that they had in 1800s, maybe not. Hey, Central. Hope you're doing well. This is shit. Scheisse ass. You hate anything with electricity? I used to be the same. I've grown to like it though. I saw that, Jasu. Le Chatelier. Principal. Le Chateliers? Principal, I should say. I know this is like a guide on how to pronounce it, but this little symbol here looks like an integral. So imagining it's the integral of a backwards e apostrophe t epsilon, whatever. That's that. That's true, Lucas. If you were born in 1800, you wouldn't be alive right now. We say this is the hardest conceptual topic, electromagnetic and stuff. Yeah, that's a very personal thing. Electricity magnetism is pretty hard because we have very little intuition for it. Like with mechanics, you can imagine a ball rolling down a ramp or whatever. It's a lot harder to imagine, potential difference and stuff like that. And for me, it's not the hardest concept though. Uh, that would go to like general relativity or something like that. Kung, you posted a question in Discord. Is this JE? This just looks like JE, Kung. I'll show it on the screen, but I don't think I can do this. Like I've seen questions that look like this before, and it's just gonna be crazy, and I won't be able to do it. Yeah, I'm sorry, Kung. I can't do this. I'll show it on screen if someone wants to try and put an answer there in chat or speak up in the Discord, but I can't do that. Bloxy main, yeah, the thing I was looking at on Wikipedia is a chemistry thing. Yeah, that looks like a kind of crazy question. It's going to use something that I haven't learned before, and I'm not going to be able to do that. Lucas says the answer is D. There you go. But yeah, we were looking at Lenz's law, and I was curious to see the Le Chatelier's principle. It's apparently the equivalent. Actually, let me actually read it. Chemical equilibrium. Quick math versus correct math. Yeah. If you guys write essays in Finnish, that's likely harder. Probably, yeah. I would have an issue with that. You actually, oh, you did. Some type of motor does. Let me translate that. A DC motor. I haven't learned this to be honest. Harris phasor diagram of transformer with load voltage. I'm sorry, I've never done that, Harris. Okay. Well, I think I understand what's happening in this diagram here. But this looks like a more realistic diagram. I have no clue what the hell is happening there. Yeah, I'm sorry. I don't think this is. I'm not going to understand the complicated version of this quickly. I could explain to you why a coil if a coil has current running through it and it's in a magnetic field, I could explain why that's going to rotate and produce torque. I don't know whatever the hell is happening in this like second image here though. That's what you don't understand? Okay. Then let's go over that piece at least. Um Okay, so basically, these are the two magnets on the side. You have a north and a south end. The magnetic field is going to point from north to south, just horizontally. And the current is flowing through this coil this direction around with the arrows. And so if you know the direction of the current and the direction of the magnetic field, you can find the direction of the force. So you might not have learned this notation, so don't worry about it if you haven't. But the force that we're interested in here, if I'm getting this off the top of my head right, is no. No, I'm gonna get this slightly wrong, that's gonna annoy me. It's called a cross product. The Lorentz force, yes. And I just don't want to write it down wrong. QV cross B, there we go. QV cross B is, and there is a second piece to that Lorentz force, but we don't care about it for this, I don't think. Because we're just caring about the manipulation. I think technically there's plus and then another thing, but we're just worrying about this piece of it. Hey, Dumwood. And so how you do this cross product is V is the direction of the current, B is the direction of the magnetic field, and the cross product points in the direction of the right hand rule, which I'll explain in a second. So look just at this piece of the coil thing. The current is flowing that way through it, so that's the direction of V. FBI. Oh yeah, for the, that's another thing too, for the magnetic field of a wire. Current and magnetic field are, if they are the same direction, then there's no force, Doomwood. They have to be pointing different ways. Um, okay, so V is pointing that way. The magnetic field is pointing towards the south pole there. And so with the right hand rule, you take your hand and point it straight in the direction of V, and then curl your fingers. Sorry, have your thumb out for this. You point your hand in the direction of V, whatever comes first in this cross product, and then curl your finger towards V. And wherever your thumb points is the direction of the cross product. So if you imagine doing that in this situation, the cross product is going to point up. And that's where the force is going. That's why they have that blue force arrow drawn right there. And so that's the right hand rule. It's using more things than just that. It takes some visualization, but they have a diagram of it, I think. Oh, this diagram, they show it a different way. That also works, though. Uh, this is the thing that's easier to explain in person when the direction I point my hand makes more sense, unfortunately. But I know you kind of need to like do it for yourself. Like you need to imagine pointing your fingers in the direction of the current. Like the current is going that way. The magnetic force is going that way. So you need to imagine your fingers pointing along the current and then curling towards the magnetic field. And then your thumb is the force. Calvin, yeah, sure. Feel free to put it there in chat or put it in my Discord. Doomwood, well, it depends what you like. Current and magnetic field. You can have a current in something else's magnetic field, or you can have a magnetic field produced by a current. In either case, well, sounds good, Dion. I'll look at it in a minute. Um, Nico, I see what you're saying. I'll read it in a second. So, Doomwood, if you, I'm not doing that, Calvin. You can look at Black Pen Red Pen's video if you want. I'm not doing that though. Uh, so yeah, Doomwood, I'm not sure if you're talking about the magnetic field produced by a current, or if you're talking about the interaction between a current and a magnetic field, or a charge in a magnetic field. Yeah, I'm sorry, Calvin. That's just like a challenge integral. I'm not really interested in doing those. I can link you a video that does it because it's just a pain in the ass. It's not really fun. Is that his video? There, that's the one. There. Oh wait, no, that's just tangent. Sorry. I guess it's gonna be that one. So there you go. Eddie, only if it's basic. I'm not very good at physics. Two different right hand rule. induced by a current through the wire. But here's a point with the current, middle fingers with magnetic field lines. I know there's a different version of it where you imagine like screwing something in or something. But for just a cross product, you can always use the right-hand rule like I said, I thought. I'm not sure. I'm not really sure what you're describing there, Nico. I don't know. Aeon, I'm getting to it. Eddie, A-level physics, you can try to post it if you want. I can't really make any promises with it. Uh, I mean, if it's just Nico, I heard it. The only other version of right-hand rule I've heard of at least is for the way magnetic field points due to like a loop. Like if you have a loop of wire with a current running through it that way, there's a right-hand rule to figure out which way the magnetic field points up or down. That's the only other one that I can think of. If it's just a cross product, I think what I said is okay. But I mean, I'm not that confident in a lot of this stuff, so who knows? All right, see you, Lucas. So you want to see partial fractions, Ion? We can do that. Okay, so wait. Not the amount of homework I have is way too much. I hope you didn't miss what I did there. Oh, Don Factorial, duh. Yeah, I get it. Okay, nice, Lucas. Yeah, Nico, I'm pretty sure for the Lorentz force, like we were talking about the DC motor. I think the curling the fingers thing that I said, I think it's okay. It gets the right result at least. I remember being taught in physics during E&M. I think for this exact purpose. I don't remember though. It's been a long time since I took the actual class. Okay, so Ayan, with partial fractions, they're being as nice as they can be to us, and they already give it to us factored. We have two linear terms here. So we're going to split it up like one term for each piece. So we'll have... Oh, wait, I'm sorry. No. I just noticed, I think with partial fractions, you need the degree on top to be less. I think we need to do long division first. Do we? Hey, Dessen. You know what, Ayan, let me plug this into Wolfram Alpha. Because we might need to do long division first, and I can't quite remember. Okay, you're saying that we do need to do division? That sounds right. It's been a minute since I've had this exact case be given to me. Yeah. That looks like we need to do long division first. Okay, so let's do long division. It's kind of annoying they gave it to us factored in that case. The current flows parallel magnetic field on the front and back side. Oh, right, yeah. I should have said that to Luke. I forgot. But yeah, we that piece we don't care about. That piece we don't care about because they're parallel. Okay, so in that case, since we want to do long division first, I think we should multiply out the bottom. I can't remember the reason why. Like that's why I'm kind of hesitating on this. Um, I just remember that if the degree on top is equal or more, I'm pretty sure you need to do the long division first. Or synthetic division, I guess. Well, no, we can't do synthetic here, right? Yeah. I agree. It is annoying. Um, I forget why, but you get something that doesn't make sense or a wrong answer or something if you try to do partial fractions immediately. It did, but the person asking the question will be able to do this on their A levels, so. AX squared BX? Well, no, this isn't partial fractions, though. This is pretty crappy partial fractions. You'd have to do long division on that piece, I think. I remember to solve that one in particular, that's why you're stuck. Really? So did you already try the long division way? You didn't try it? Okay. Yeah, I forget the answer to that. Like I've tried to run into something weird, but it if the degree on top is too big, I do think you have to do this. So if you do the long division, you just get 1 minus x over x squared plus 4x plus 3. I see a touchable. I think I can do that, but you'll be after this question. Okay, but at least on this piece now, we can do partial fractions for sure. So x over x plus 1 times x plus 3 would be something like a over x plus 1, the first term, plus b over x plus 3, the second term. And the way that I do partial fractions is there's tricks to do this faster. I can never remember them. I just multiply both sides through by this denominator and just deal with doing a little bit more fraction math. So on the left side, we just get x. Sorry, just to be a little more specific about what I'm doing. Taking both sides of the equation, multiplying by x plus 1 times x plus 3. This a, the x plus 1 will cancel, so we just get a times x plus 3. For the b, the x plus 3 will cancel, so we just get b times x plus 1. Multiply things out. And now we're going to equate coefficients. So everything with an x should have to add up to equal the 1 in front of the x. So a plus b is 1. So Ranger, Uh, oh, that's the trick to do it faster. That's what you're saying. That sounds familiar. I guess you do it in this step. Oh, okay. Yeah, the way that I the way that I remember hearing it is something about like covering up everything with x plus ones or something, but I can never remember how to do that. Um, okay, let me just finish it. I just want to show like doing it the long boring way, and we'll try your shortcut. Uh, One equation we get is a plus b equals 1 from all the x's, and then if there's an x plus 0, so we can also do one for the constants. 0 equals 3a plus b. That's two equations and two unknowns that you could solve to get the a and the b. But I'm curious to try Zone Ranger's trick. If x equals minus 3, you would get minus 3 equals minus 2 times b. So b equals 3 over 2. If x is minus 1, we get minus 1 equals 2 times a. So a is minus a half. Does that actually work? Oh yeah, it does. It checks out with the equations, right? Okay, nice. That is a lot faster. Thank you, Zone Ranger. And yeah, that's the way that you use too. Okay. Well then from this step, I think we're just done. A is minus a half. B is 3 over 2. So we can shuffle things around to make it look a little nicer. But yeah, I think that's the answer to part A. I'm kind of curious, like, why do you need, or why can't you do partial fractions and the degree? I'm just kind of curious about that. Oh, interesting. If you have, okay, it comes from the assumption that we make with how this decomposition can possibly happen. If you take these and put them back together, the highest degree thing you can possibly get is degree 1. That's why you need to do the long division or use some other trick if the degree on top is the same or more. So yeah, Ayan, I guess was your question about the long division piece of this, or um I guess now that I know where the question is going, like, was there a part of this that you were particularly confused on that you want to hear more about? Okay. Yeah, that's the thing. I remember I've been tricked by it before, but you have to do the long division. Now put the link for that second change 30 spinning y in there. Okay, so we have a question from Touchable with an integral, and then Najaf is asking about log properties. Another way to do partial fractions? No, I know there are tricks to do partial fractions faster. The thing that I hate more than doing things slowly is having to memorize things. So I just do it the slow way. That's more intuitive. No, Najaf, I can help you with your question. I'm just trying to prioritize what I'm doing first. Black pen, red pen, I think, has a video on doing partial fractions faster. Let me try and find it. Black pen, red pen. Partial fractions. Yeah, he does. The cover-up method is the one that I've heard of. I just can never remember it, so I don't bother with it. Okay, so I want to quickly answer Najaf's question about the basic properties of logarithms, because that'll be quick. And then Touchable, I'll do your integral. Let me just get them, find a website that has them written out. Oh, since I know the solution? I don't know. Do you think I think critically? I started to know the long division is unavoidable, and going through partial fractions as we did it is I don't know of a way to avoid it. Okay, so Najaf, or I hope I'm saying that right. You're noticing the third one. Okay. The third one, all the third one says is that if you have log of, say, log base 10 of 2 cubed, I was actually just thinking about this exact thing the other day. It's kind of weird, like, that this does work, but if you're taking log of something to a power, the power can come outside as a multiple. So this cubed, the 3, can come out front. And that's different. There's a big difference where it would not work if it was log base 10 of 2, all in parentheses, cubed on the outside. This is an entirely different thing. But if the power's on the inside, if it's on like the input of the log, you are allowed to take it outside as a factor, like being multiplied. That's kind of all there is to it. Like, if it is a little bit weird that it works, but I think there's the derivation of it. Okay, I'm going to make you wait for that because Touchable did ask the question first, and that's going to derive will take a little bit longer. We can try to derive this after though. But yeah, Touchable asked their question first, so I should get to their question. Makes more sense to consider applying that exponent. I like the second thing, Jed. Okay. Oh, fair enough, Jed, yeah. Yeah, Najaf, that's fair. People just for the reason they just love to spam their problem 20 times, and I got really annoyed at that. Um, so that's why it's on a 30-second delay. But if people behave themselves for long enough, I might reproduce it. People just really love misbehaving though. Um, I would not believe that touchable. No, this is really advanced for a seventh grader. Uh, I would worry just about the integral up here in the exponent first. Just completely forget about the e down there for now. We'll deal with the integral first, and then the e will come at the very end. I assume you're studying independently or something, because this is kind of crazy if you're doing this now in seventh grade. I'm just going to do this in black. I would do this integral with a u sub. I would take u equal to e to the x plus 1, and d will be e to the x dx. You asked it for fun? Oh. Uh, can I ask you to not do that? Because I prefer to be here for homework help. Um, it's gonna be a u, and then there's gonna be an e to the x here. We could sub that out. So yeah, okay. If you're asking for fun, I'm gonna leave it. You have to do partial fractions, I guess. Uh, that's okay to talk spiel, but the emphasis of the stream is homework help, and so if people start asking me questions for fun, it gets kind of out of hand. And I feel bad that it takes time away from people who are like trying to get through their tests. That's tomorrow. So that's why I don't like to do challenge problems, or just like problems for fun. So let me go back to Najaf wants to know the derivation for the log power property. The answer is 2. Oh, okay, fair enough. How would you derive it? I think with a change of base formula, right? Uh, oh wait, I get it. Uh, there's a really okay. Assuming that we already have okay. If we already have the property that log of a times b is equal to log a plus log b, we can use that property for the power one. If we want to prove something about log of b to the k, b to the k is the same thing as log of b times b times b dot dot dot, like k many times. And we can split this up into a sum of logs with this property. So log b plus log b plus dot 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 log b. And again, we have k many of them. And now we can just combine like terms. So that's just k times log b. I think that's a pretty clean way of doing it. Zone Ranger, yeah, I was just realizing that my substitution wasn't perfect. Yeah. Uh, if you do know that property, there probably is still a way. Uh, if you bring it, there probably is still a way, but I think this is the most direct way that I can think of. Oh, your teacher roasted you? That's not cool. But no worries, Najah. Good luck with your tests. Hey, Nami. Okay. We can go a little bit further down the path of this integral here. Just to because we don't really know who's waiting on us now, so yeah, I think this would be the use that you want. And so we would get u plus 1 times u. And I guess you have partial fractions that uh can I be a Chad in mental math this partial fraction? I think it's be plus 1 and minus 1. I think it's 1 over u minus 1 over u plus 1. Yeah, okay. Zone Ranger agrees. Uh, Touchbolt. I'm doing it right now because no one else asked me a question. But people are just like, when I just let people like ask me really like, when the people just ask me questions for fun, they tend to be challenge questions that take a lot of time, and the people who are trying to get their homework done and prepare for a test that are now have like less time for me to respond to them, which is why I don't like doing them. Uh oh, that makes me happy to hear. Najah. No worries. I'll see you around. Now we can unsub. We'll get x minus ln tx plus 1. That's always positive. So we don't need absolute values. From 0 to infinity. That's going to be L'Hopital's. Okay, this is where I don't feel like doing it. I I can do this limit, I just don't feel like it. So I'm gonna stop there. Well, I can plug it into Wolfram Alpha, I guess, but I'm not doing it by hand. What happened to the base? I just am ignoring it for now. Like my thought was to bring it in at the very end. 0. Which means the only thing that matters is plugging in 0. That's 0. That'll become a minus negative ln of 2. And so then you do e to the ln 2 back over here, so you get just 2. There you go. Okay, I was working on this question for complex analysis. Oh god, that my back just cracked. Oh man. Sam, if you have specific questions, feel free to ask me. If you're asking in general, I can point you to a nice resource for it, which is Paul's Online Notes. I really like this site. Just looking like the sidebar up here through Calc 1 through Calc 3. They also include like the algebra that you would need to know to get through calculus. They provide pretty nice example problems. Exactly, Paul's Online Notes shill. You know me, Jed. But yeah, so if you want, you can ask me a specific question about like a problem or a concept. But if you're just looking for a resource to go through calculus, I do that. Oh yeah, I guess that's another way of doing it, Touchable. The way that I did it works too, though. Abbott greater than Paul. I've heard a lot of people talk about Abbott. I don't actually know what book he even wrote. Teach Yourself Calculus. I don't think I've seen this one. Or Understand Calculus. I don't know. Why is there a limit in calculus? Well, it has to do. I don't know what you mean with the factor. But limits are a really fundamental thing in calculus because understanding calculus. Oh, okay. Limits are really important in calculus because if a limit isn't involved somewhere, it's not really a calculus problem. And what I mean by that is calculus is the two primary things in calculus are derivatives and integrals, and they're both defined in terms of limits. So a derivative is defined with limit. I don't think Paul goes over it, but an integral can also be defined with limit. And so they're in calculus because they are calculus, basically. If you don't have a limit, you don't really have. I mean, maybe. No, I don't think you really can have calculus. I was wondering if there's a way you could somehow avoid them or talk around it, but I don't think so. Who is the father of calculus? Calculus, who's your daddy? You know, calculus will be in the unfortunate situation. It would need a DNA test or something because calculus has two daddies, Newton and Leibniz. You know, to deal with infinity and still do. Infinity is a pandemic deep rooted within the math community. You're only a fan of finite things, Desson? Talk Schwal, I'll pass. Gonna learn neurology? I don't know if that's gonna be much easier. It sounds difficult, but you know, if you enjoy it more, that's the important part. It's like saying that becoming a lawyer is too hard. I'm gonna go become a doctor instead. It's gonna need analysts about defining continuity and infinity, and most will go blank. Wait, continuity? I feel like analysts have continuity on lock. What's wrong with continuity? Infinity, maybe, but um, the place I got into my work was here, and so in order to apply L'Hopital's here, they're saying this would only work if everything is zeros all the way down. I assume this is the place where we would see that. Aren't these multivariable functions? How does L'Hopital's work in multivariable? No, they do not. Only convincing one to me is the top definition of continuity, and still does not bother defining it. Hey, Nikhil. I never thought there's anything inexact about like the epsilon delta way of defining continuity. I remember looking at the topological one before, and I could kind of understand it. Um, I'm from America. Do I was am I taking the wrong approach here? I don't really know how Lapidus works in multivariable. I assume we're not supposed to do this would be a pretty complicated derivative too. Can someone share some weird science fact? I don't know. Yeah. Oh wait. Maybe I should have thought about the given information a little more. What country do you think has the most math culture? France and Russia come to mind immediately. Like Germany and the UK should also be in the conversation. Um, I've heard of IIT, yeah, Nikhil. Uh, well, I'm thinking about historically. It's like Empire is saying like, what about USA? America's kind of a little too young to have that like tradition. I'm just trying to think of like when I hear about mathematicians where they tend to be from historically, and a lot of the important ones existed before America existed as a country. So I also feel like I'm leaving out like Asian countries too. Like they've had a lot of good mathematicians that we just don't really learn about. Einstein did come to the USA, yeah. Honestly, that's another point though. A lot of what the USA does is we take other people's scientists. Oh, I have heard that, Sam. No, I'm just a tutor, Nikhil. Okay, so here's where we can repeatedly apply L'Hopital's a bunch of times. I guess K many times. Oh wait, no, no, no. We can't apply it. No, 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 no. I've heard of Schrodinger's equation. I can't explain it though. Things now have just spread around the world more than 2 decades ago. Other countries hold math, congress, or big events or seminars. Yeah. I guess I agree with that. I don't know. What else to say about like it's kind of like you also have to like know. I assume academic papers aren't typically published in non-English languages, so that's another way that like Western countries tend to have an advantage. Yeah, I guess it's like countries around the world develop, they'll start like mathematicians will start like spreading around the world and being more common in every corner. Haley Hamilton theory, I've heard of it, but uh, I don't really know it. Um, Nikhil, please don't start talking about that. In fact, I'm gonna delete it because when people I've had many people ask a question like that, and it just devolves into arguments and things that I just don't really. I just want to talk about math. And yeah, Empire, you can't say that either. Now the unfortunate thing is I can't erase that chat, or I deleted it in YouTube, but I can't actually erase things from the chat that's up there. So let me just spam. Sorry about this, guys. There we go. Just to get it off the screen there. If the first k derivatives are zero, I think you can say s1 equals 0. Ooh, really, Lubert. No, Joseph. The YouTube chat was being YouTube and saying weird things, so I wanted to get it off of the chat that's up there. So if I delete a message in YouTube, I think or in Twitch, I can't. It still shows up in that chat, which is annoying. Sam, I've been to Chicago. I don't know if you're talking about a place in Chicago. No worries, Nikhil. I just don't like. That's not the first thing the conversation has gone that direction, and I'm just. I tried to avoid it because of things like what Empire said. So. First k derivatives of f are 0. Hey, MBM, you're from the UK? Must be late for you. Welcome in. Does a sub n have to be 0? Evaluated at a. Okay, yeah, I think I get your logic there, Lubert. Because a isn't generally 0. So in order for these derivatives to be 0, a sub n and b sub n would have to be 0 for the first few things. Okay. So a sub 0 through a sub k equals 0. Same with the b's. Oh! Yeah, you're right. Okay. I did mess that up. So we don't get that trick then, I don't think. See ya, Ashu. Simpsons, that's not possible. Yeah, my biology final A-level today. Your math was yesterday. Ooh, I hope you did well. Trolley problem? I think I've heard of that. I don't know what it is. I probably can't. Nikhil, no, I can't. Sorry. It's true back then and still is true now that a kid in the lowest, say 20% of poor students that won't see her chance to become a mathematician. Oh yeah, I mean that's something that I just don't really have much perspective on at all. But when we say 20% of poorest families, do you mean globally or in a certain country? Because like the poorest 20% here in America have a very different life than the 20% poorest people globally, for the most part. All right, see ya, Nikhil. Uh, Anthony, it's been. Why would they have to be zero? If we're plugging in z equals a, basically, or limit of z equals a, that gives us the zero already. Am I missing something? Well, I probably am if you both agree. But I don't see why a sub n has to be zero. You differentiate it n times. When the exponent is zero, that too. Like, are you talking about like the formula for a Taylor coefficient? Like a sub n is f and I'm double using a here, which is bad. Like, is this why? I don't know if a Taylor series and complex numbers are the same, I guess. We're not doing permutation in combinations, Nikhil. At least, I mean, this is a factorial here, but right, the mth derivative of f of z in terms of the power series. I'm not sure what that is, Nikhil, but good luck. Um, what would this last term be? Uh, just n minus m. There might be a plus one or something. Oops, the exponent is different as well. MCA entrance exam for PG degree? Okay. Well, good luck with it. I was just wondering about the start of the sum. Uh, I was going off of this formula that the book gave. I wonder if they did some index thing. I forgot the a sub n, I think, as well. I wonder if they just like turned the index forward or backwards to deal with that. Because like you're right, this does feel a little bit weird to me, the way that it's written. I just maybe I need to see it term by term because I'm gonna get confused on this. Okay, bye, Nikhil. Okay, so the first m terms go away entirely. So let's maybe we'll mess with the indices later. Abhinav, oh, induction isn't a bad idea. I want to see if we can make this work, but that might be a thing too. Um, do, 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 do. Is that the more direct way of writing this? Uh, I feel like it's n minus 1 factorial. Just as a more compact way of writing that. But yeah, apparently, okay, and so we're saying that this equals 0. Was the point of doing this? We know this isn't 0, but the issue that I have is that, well, in the limit it equals 0, right? The exponent is wrong? You're right. Thank you. The thing is, it's of a is 0. So if I evaluate this at a, I do get 0. Like, I get 0 from z minus a, not from a sub n. That's what I don't understand, Hamiltonian dynamics. Tyler, is it the one where they're at like some type of hotel resort thing? Because I've been getting an ad where there's like three dudes at some type of like that one. Yeah, they have distractingly perfect teeth, like unrealistically perfect Hollywood teeth, and it's kind of annoying. There is a fly. Go away. No one likes you. You have no friends? Okay, I think it went away. For now. It'll probably come back because there's lights on. There should be a term with z minus a to the 0. Well, it got derived away, didn't it? Oh, wait, no. You mean like in the derivative there should be a constant term? Uh, you're right. There should be. What's the question currently, AFK? Can I underthink it and do that? Indu, my name's Don. I have a bachelor's in applied math. I'm from America. I'm just a math tutor. Right now I'm working on a complex analysis question. Currently FK. Okay. I can't help with JE questions. I've tried them before and I just can't really do them. So I'm sorry about that. But if it's a JE question, I can't really do it. Sorry. I feel like I'm doing the, I haven't really taken enough care with these indices. It's annoying when it's the mth one. There's a constant term multiplied by a sub m. Okay, I think I see what you're saying. Yeah, I think I understand now. Hamiltonian dynamics. It's because of the constant term that each of these are forced to be zero. Okay. The first k terms of the series, or coefficients. You start your career as a theoretical physicist? I mean, I'm not one, so I have a hard time recommending, but uh, I if you're just in 10th grade, I would just try to kind of get inspired to learn more. So like a channel I recently found is called or was recommended is called Floathead Physics on YouTube. Um, he makes some really good like physics videos that I think would be good for you to watch. Yeah, I'm getting lazy right now, but I want to get this derivative more properly at some point. But I think my something needs to be turned forward or backwards here with my m's and n's. I just don't really feel like doing it right now. But if we take the conclusion, which is ultimately the same, which is a sub 0 through, I mean, I guess a sub 0 through to a sub k must all be 0. And same with b's. N minus m plus 1. So if I did it with my like little shorthand and simplified thing here, it would just be the first thing that I thought there, m factorial. And I think zone, would this start from m? Yeah. I think. I have a bachelor's and I'm going to start in a master's in September. Thank you for that zone. And so the point of doing this is that we can say the first whatever terms of this series are going to be 0. And presumably we can get, oh yeah, actually it is good to be more exact with the indices here, because I think we have to claim that this equals this, which maybe I can just say that without. Oh wait, no, not exactly. This wouldn't be the same, but it's just a constant. In fact, it's the same constant. It would cancel out from each of these, right? Actually, with the summation, that's not good. Uh, Renga, that's exactly it. Yeah. They're very angry little letters. Let's say that sum is a sub m at z equals a. Um, I mean, if it's JE, I can't help with it. But if you have a question, you can put it there in Twitch chat or put it in the Discord. I'm not going to be streaming for much longer though, so it's not. Oh, there's not much time left. Um, oh, we're using m before just be generic. This should technically be k. I'm this still isn't the exact thing that I want, right? I want to find that it's exactly the derivative, so I can just plug in. Well, what am I looking for? Do I need to do like a? Yeah, and so I should rewrite that out. Well, I don't think they necessarily cancel though, because this is summation. They're still inside the sums. Uh, Oh. I won't do an entire one, Hashim. I can do like maybe an individual question. Um, to be honest, I'm probably gonna wrap the stream up after this problem though, so I'm not sure if there's gonna be time for another question. It kind of does, Hamiltonian dynamics. That's part of what's giving me trouble here. uh, hmm. 'Cause I don't think the z minus a's don't completely cancel. The first k ones do, but each term will have different powers after that, right? Or the first k plus ones will cancel. Oh, that's what we can do. Okay. That's a step in the right direction. That gets us that. Yes. Um, you want to write out the fraction, not or the summation. I'd like to just understand it, but might have to go that far. I know for up here. I just want to see if I can figure out a way to figure out how to get this coefficient here. The thing that I don't like is like it is increasing for each thing. Like I can't just multiply by something over something to get it. No worries. Oh, wait, yeah, what happened to the limit? I just realized there's no limit on the right-hand side. Okay, so maybe we do. What? If I evaluate at z equals a, don't I zero everything out? Isn't that bad? Except for the first. Okay. I keep forgetting about that, yeah. What is that? You're saying that's f of z over g of z? Well, don't we want the k plus first derivative? A sub k plus 1 proportional to the k plus 1 derivative of f at a. Oh my god, okay. This is... I need to go back and think about this one a lot more. I think I get what you're saying now, though. This one is a lot more subtle than I thought it'd be. I thought we'd be able to just kind of make it pop out a lot more clearly. But this is kind of a sneaky one. Thank you for your help with that. Hamiltonian dynamic zone, Lubert. I'm sorry to hear that, Storm. Good luck. Okay, we might wrap it up here for the day. Wait, is Zach not streaming yet? No, I think he is. Let's see. But I gotta use the bathroom, and I've had to use the bathroom for a while. Armand, the point was to try to prove L'Hopital's rule. So it wouldn't be good form to use it. Unless we could find a case where it's like real. But I'm gonna end the stream here, guys. On Twitch we'll read out. On YouTube I'm just gonna cut it off here. I do appreciate the help though, Armand. Thank you. So yeah, anyways here on YouTube, thanks for being here. I'll be back on YouTube on Saturday. Goodbye, YouTube.